Hello. Hello. Hi, everybody. My name is Maria, and we are going to talk today about data structures. Um, okay, let's slowly start then. Today we are going to talk about data structures and algorithms for FAANG interviews, but it is actually helpful for any coding interview. And my name is Maria. I work as software developer, data engineer, software developer and test in different companies. I have more than 10 years of experience and I did interviews in different companies. So yeah, I hope it give you an overview. And let's start with coding interviews and resources, how we can prepare for this. First thing is that you can practice on your own for preparation. It's best known probably is LeetCode. It's also interview cake, like cracking coding interview book. It's quite well known resources where you can find some tasks. The other thing I wanted to highlight that it's actually important to during your preparation also practice with others. That's why I like Pram, but it's just one example. There are several different services that matching you with different people with whom you can practice interviews. And I think it is really important because during the interview you will you don't know the interview. It may be person from different country with different accent, very and it's important to try and to learn how to communicate your ideas and thoughts to them, to some random strangers. I find it very useful. Another thing is just before I'll go with a few more best practices that I find useful during preparation. And first thing is know your tools. You are gonna do the interview in some specific language, and before the interview, review your language libraries, review some specific things about its data structure implementations. It's really useful because, for example, in C++, you have a lot of very powerful libraries that to manipulate and work with data structures. And in Python, for example, you have lists that are not actually lists. And it's when you are starting to go into discussions of the complexity and other things, it might really matter what it is under the hood. And also during the preparation, I would say thing is important like quality over quantity. So I know people on different forums, they are writing that they solve like 500 LeetCode questions, 300 LeetCode questions. It's a lot, but I don't think it is, you also need to try to beat those numbers. I think you should invest in quality of your preparation. And for this, I suggest one exercise that I found really useful during my preparation, and just it is just an exercise. It's like, do not think about it in any other way. And so how you should do this? You just pick the question. You want to solve something, you can't come up with the solution from the top of your mind. After that, like, close everything, any suggestions, any websites, everything, close Google. Try to come up with the algorithm. If you can't come with the solution immediately, think about this. Think about some brute force solution if you can't think of something better. Just come up with the solution. If it takes like 10 minutes, it's okay. If it takes 20 minutes, it's also fine. Just do it. After that, explain it loudly. As I'm saying, it's just an exercise. And think about complexity of the solution. This is important. After that, try to write code for this. Just simple code. Ever if you like forgot some libraries, forgot some syntax, try to write it without any help from IDE or from other coding tools, without looking anywhere. Try to write it. Just after that, verify the code. Just think about any edge cases. Took any example solution, example input, and try to go line by line and verify what's going to happen on this line, how this condition going to work, and so on. Like correct all the mistakes that you might find, like syntaxes mistake, logic mistakes, whatever. After that, only after that, try to actually run your code, and of course, correct syntaxes if it was still incorrect, and so on. And only after that, go and look for proper solution, explanation, how people are gonna, different approaches, and so on. Why I think this exam with exercise is important? Because it helps you to code, like to first come with the solution, and only after that go to coding. And also it helps you to code without help with any fancy tools that we are usually using during the work, and you might not have access to it during the coding. But it's just an exercise. But what I noticed that it's doing miracles. It's like first time you might spend like 3 hours on this. Next time you realize you're doing it faster, and after on 5th iteration you will do it really well. So this is first exercise that I suggest. And the second exercise I suggest is like put the timer and try to code and try to do it in the time. It is different approach because you will look on the time, you will be under pressure, you might get stressed, and it is also useful to practice. So yeah, this is, I would say, how I suggest to practice during your preparation. And let's go to the next things. It's actually, let's go to the data structures and algorithms. And just a disclaimer here, I'm not gonna go deep into each data structure, how it's working, how it's, and so on. And because we don't really have enough time for this, but I'll try to highlight most important things and trade-offs you might need to do when you are considering to use this specific data structure. And yeah, first thing is complexity. For algorithms, we have time complexity, we have space complexity. And it is trade-off, and you will need to make when you are coming up with the algorithm for your solution. And it is something that is important to understand before you actually start to code. And for example, if you have several ideas of how the problem can be solved, complexity is actually how you're going to compare it. And also, when we are talking about algorithms, we are usually talking about worst case scenarios, but we can have like best case scenarios for complexity, or average scenarios. Like, for example, if we are talking about sorting, if we have array that is already sorted, in some cases it means we don't need anything, but how our algorithm will behave there. Is it gonna really spend n log n or not? So yeah, complexity is very, very important, and understanding it is important. Yeah, And now let's go to data structures. So very, very basic things. We'll start with this. We have arrays and lists. And what is important to remember about this is that for lists, lists are easy to manipulate, and easy to modify. You can add elements in the middle. It is quite cheap because for list you just need to change a few pointers to make it work. While for arrays, it is usually more expensive because you need to reallocate whole memory and copy all the data there. After that, arise the initial version. And if we are having really big arrays, it will be a problem. And this is, I would say, what's important to keep in mind. If you, in your task, it's required a lot of data manipulation and adding elements in the middle, maybe you need lists. Yeah, but in lists, to find some specific element, it always will be on, no matter what you are going to do. And in arrays, you can actually have a binary search that is giving you complexity log n for lookup of the element. Yeah, that's next thing is we are going to talk about sorting. And sorting is like, first of all, I would suggest you to just choose any sorting algorithm and just implement it for the sake of the exercise, just to get a feeling how such things are working. It would be useful. And what is important to remember about sorting are that there are different algorithms, and one of them is in-place sorting, and the other one is out of place. It means like in place is when you are not using additional space, and out of place is when you're using additional space. It is important and it can be crucial in some tasks if you don't have enough memory, or if copying data is not a option for you. This is important to keep in mind, and also it's always worth to mention during the interview if what kind of sorting you need here and why. And complexity, it is n log n, as I put here usually, because there are a lot of algorithms, and some of them giving you worse complexity, but some of them, like for example count sort, it's not applicable in all the cases, but when it is applicable, it can it's sort in linear time. Nice to know. And we have bubble sort, and while bubble sort is in general known for n square complexity, it's actually can show very good results for semi-sorted arrays and almost sorted arrays. So this is something also to remember. And one other thing to mention about sorting algorithm is like merge sort. It is easy to parallelize, and if it is something that required in your question, or if in your question you have like task to deal with huge amount of data, it is something to use then. So yeah, next thing we are gonna talk about trees. And I put here this ugly tree just as a reminder that when in the task we are talking about tree, not all the trees are actually balanced by default. And not all the trees are binary. And just to remind you that balanced tree is like tree structure where leaf is no more than the difference in the height in the distance from one on the leaf to the root and any other leaf is no more than 1. And it is very important for specific tasks. So I would say here, do not assume by default that your tree is balanced if it's not stated in the question. And do not assume by default that your tree is binary, because it might not. But it's also important to remember that in the tree, find any element is just some random tree. It will be ON. You just can't get away from checking every element. So yeah. And yeah, of course, there is no loops in the tree. But here we have binary search trees. It is special type of trees, and it is also called like ordered trees. And in binary search trees, each element in the subtree on the right of the node is greater than each element on the left side of the node. And it is very important property of the tree because it allows us to look for elements in the tree for log n. And I'm like constantly here referencing to during my talk to the complexity, because yeah, it is what you need to think about when you are deciding which data structure you are going to use for this, for your specific task that you are trying to solve. Okay, so it's binary search trees and how we are going to deal with trees. There are two main things how we can do it. We can do breadth first to traverse the tree is when we are going level by level, and depth first when we first go into the deepest to the leaf, and so on. It is two main algorithms, and to be honest, I never really recall specifically about this. I'm just, by looking on the task, I'm deciding what we need for this specific task. And yeah, but actually for doing and manipulating with the trees and solving any task with the tree, we need to traverse with the tree. And for traversing the tree, we need recursion. And I can't stop myself from putting this map here because I think it's like best explanation of what this recursion is. But if we are looking in the wiki, we will see there that the recursion is a process a procedure goes through when one of the steps of the procedure involves invoking the procedure itself. A procedure that goes through the recursion is said to be recursive. And I put here an example of the function. It is Python, just in case. And it is a function for classical recursion question. Fibonacci, I think like everywhere when it's starting to, in every manual, if it's explanation of the recursion, they are taking Fibonacci numbers. And here's a solution for this that I wrote for you to show you how it looks like and how it is. But this is actually what I noticed, that sometimes people are a bit struggling to write recursion in functions, or to understand recursion in general in this way. And I would say there are actually a ways where you can how you can deal with this without you can use simple loops that are actually quite significantly easier to debug. And for that, before we are going to use it, we need to review two other data structures. One is stack and queue. So queue is first in, first out. You can think about this like this. That is one structure. We are putting elements there from one side. We are taking elements from the another side. And we have stack. And in stack is like it's like a glass. We are putting element from only other side. And we can use it to traverse a tree and without recursion and just with simple loops. Here it is. I wrote two examples that are very, very similar. Again, this is Python. But this is very, very similar. And how in general this algorithm is working. It is like if we will take queue, for example, we are putting root element in the queue and going into our while loop. After that, we are taking root element, process it in the way we need to do it for our task. And after that, we are taking both children of this element, like as many children as we have in the tree, and pull everything in the queue. And on the next iteration, we are taking out first children, and so on and so on. And I find those approach is quite significantly simpler to debug. It's easy to come up with if you need to do something complex with the tree, not just as here print out something. And the important thing here that it is exactly the same complexity and time and space complexity as the solution I wrote here. Because when we are writing recursion, we are actually using using memory on the stack, and so it's we can't say about this specific solution that it is using constant memory, because we are using memory for the stack. And here we are using memory for queue or stack. Depends on what we are using. So it's like identical in time complexity, identical in space complexity. And you can use this just easily if it is simpler for you. But some people find this approach simpler. It's up to you. It just usually good to remember if your programming language you are using is if it is like recursion tail optimization there, just in case such questions will come up in the interview. And final thing, Hashmap. Hashmap is this is like common mem that every coding interview you can solve with Hashmap. It's not true, but I would say a lot of questions are required Hashmap. And Hashmap is data structure that contains key-value pairs, and it has almost constant time for lookup for keys, and it is its advantage. And but usually what trade-off comes with the Hashmap is that to build in Hashmap you need additional space, and of course you need to traverse all your data to put it in the Hashmap. And so usually it comes like with this trade-off. Is it like time or space? But Yeah, it is very important. And if in your specific task is required to access a lot of elements by its key, then probably you need Hashmap. Okay, I think, yes, that is all I wanted to say. And here we have questions. Any questions? Okay. Map and hash map, it's, I would say, like, it is not, but check your specific implementation for your language. But in general, when it's said hash map or map, it can be referenced by, it means the same thing. Yeah. Python has dictionaries. Yes, that is inbuilt hash map. Amortized time complexity for what? What is amortized time complexity? It is, I would say, you can talk about this as approximate. Like, for example, for some algorithms, uh, mm, if you are gonna do, it's, how to say, I would say, think about it as an average time complexity. It's like when worst case scenario is would be different complexity, but in general it gives the amortized time complexity. Usually, I mean, if we are talking about mm, coding interviews, usually it's meant like normal time complexity. Amortized time complexity, I would say, it's like a bit of how it is calculated. What to do if you don't know how to solve a problem? I would say, like, first, do not panic. Take some time to think, and if speak out loud, share your ideas. I mean, with the interviewer, of in which direction you are thinking, and try to come up with very, very simple, like, brute force solution, and share that there is like this brute force solution that you can use, and yeah, and start working from there. It's better to have some solution than no solution at all. Okay. Any more questions? What do you recommend specializing in one and going full stack? I would say it's totally your preferences. Up to you, and what do you want? And what do you feel would be more interesting for you? Should we always use memorization in recursion? Oh, I would say probably depends on the task. I would say carefully here, but it's more, I would say, about the language as how it is implemented in your specific language. Uh, okay. Okay. Any other questions? Uh, there is no specific formula that I know to calculate space complexity. It's just you are looking, for example, if you have an array, it means the size of the array is would be like space complexity you need. And so yeah, it's like amount of memory you are going to use during the question, during your algorithm, during work of your algorithm. Yes. Like interviews, I expected good practice in coding interviews or good coding practices. I would say yes. It's my personal opinion, but why you would like you would write ugly code on the interview where you supposed to impress the interviewer and show that you are a good engineer. So do not. Why would you write an ugly code there? Um. Okay. Any other questions? Any other questions? One. Any other questions? Two. Uh, what I would suggest to increase coding speed for this, I would suggest. I mean, it is this exercise that I said, like coding without looking up for the reference. I suggest to do it because in coding speed, it's important that you are writing your code like as correctly as possible and from the beginning. If you're starting to write the code without clear understanding of the algorithm, you are actually spending wasting time. If you are starting to write like, oh, okay, I will start to write and will come with the ideas in the middle, it might feel that it would be faster, but in reality, and if you will sit with a timer, you will understand that it's not faster. Faster is first come up with the idea and after that try to code it. And that's why I suggest this exercise when you're uh like closing everything, trying to write it, and after that like checking the result. In the beginning, as I said, it might take a lot of time, much more time, like up to a few hours, but I found that this is what is really helping, because after a few iterations you will really build the habit of like first coming up with the algorithm and after that coding it from the beginning to the end fully, and after that looking with a mistake, and it will be fast in the end. uh, how many exercises I recommend? I would say it's up to you. As I said, numbers is not as important as actually quality. So I would suggest that choose exercises from different areas, and if mm, different yeah, for different data structures, different areas, different companies, and always try to code to look for the exercise that you don't know for different topic. And yeah, I would say it is better, and do not try to just beat some numbers. Best website for practicing, I would say, again, it's up to you. Lead code is very popular because it contains a lot of questions, and yeah, just find the one that suits better for you. And of course, try also to practice with somebody. It's also important. I would say I'm on login for the tree. I can try to explain it, but I would actually, in this case, if you find that you are struggle with this, that's like, yeah, it's a binary search tree. And I would actually suggest you to look for some courses on Coursera from the university, different universities, and they are explaining it usually well. I think they will do it actually better than I am. But just a brief idea that you have here, like you have amount of elements on each level, and login in this case, it is actually like half of the tree. It is it. Okay. Any other questions? Any other questions? One. Any other questions? Two. Any other questions? Three. I would say no questions so far. So thank you. Thank you for joining. Thank you for your time. And good luck with your interviews. I hope it was helpful. Bye.